So before break, we learned about mole ratios and how do we calculate if we know the number of moles of one reactant, how do we calculate the amount of other reactant needed or the amount of product that will be produced. We learned using number of moles as well as mass units. If the mass of the reactants are given, then you can convert that to moles and again use the mole ratio concept. So following on that, next topic is limiting reactants. So we know that when we mix two reactants, one usually does not react completely. We have seen that many times in lab. Maybe you haven't noticed, but now onwards, let's say you will start noticing. Let's say we have this reaction. The picture shown here is solid magnesium metal reacting with hydrochloric acid. So if you look carefully, the first beaker we have hydrochloric acid. We put let's say 3 pieces of magnesium. Can you see in the bottom of the beaker like 3 metal pieces? Okay, so it's reacting with the hydrochloric acid and there will be gas, hydrogen gas producing. That's why it's looking like so much, kind of cloudy because the gas is coming out. So picture B is still, it's reacting. C is after all the reaction is complete. Look at this picture and what do you think? Which one was the reactant which was in excess? Just use your logic. Don't think too much about, oh, we haven't learned this, so how am I supposed to answer? Just look at that picture and what comes to your mind? Yeah, A has bubbles, but you see the metal pieces in there, it is reacting. B, still you see the metal pieces in the bottom of the beaker, it is still reacting. In C, do you see any metal pieces in the bottom at all? So what happened to the magnesium pieces you put in? Not dissolved, use the better word, it reacted completely, right? So if it is completely reacted, there is no magnesium left at the bottom of the beaker. We started with hydrochloric acid and magnesium metal. Which of the reactants is in excess? Hydrochloric acid, right? If magnesium was in excess after the reaction is complete, whatever the excess amount of magnesium, it should be left on the bottom of the beaker. We don't see anything at the bottom. That means the magnesium has reacted completely. Whatever amount of magnesium you put in, it reacted completely, right? So by process of elimination, we can say there were only 2 reactants. Magnesium reacted completely. Therefore, the excess reactant should be hydrochloric acid, the other reactant. Okay, we will do more practice on this logic development. Then we will look into real chemical equations. So before we proceed, there are 2 words which you haven't seen before, limiting reactant and excess reactant. So the limiting reactant, as the word suggests, is the reactant that reacts completely and therefore not present when the reaction is complete. Makes sense, right? If something reacts completely, then it shouldn't be present at the end of the reaction. So that is the limiting reactant. So as the word suggests, the excess reactant is something which is present in excess or something which is present too much. So if something is present too much, of course after the reaction, whatever the extra amount, it will be left over, right? So the excess reactant will not be completely used up because simply there is too much of it, and some of it will be left over after the reaction is complete. Now the third point is important. We are going to use that logic later when we do the problems. Since the limiting reactant reacts completely, The amount of limiting reactant will determine the amount of product that can form. Okay, just hold on to that thought and let's make some sandwiches. Okay, we are making cheese sandwich. So here is the recipe. To make a simple cheese sandwich, you need two slices of bread and a single slice of cheese. Right? That's what simple cheese sandwich is. Okay, now let's imagine we have 12 slices of bread and 5 slices of cheese. The first question is, how many sandwiches can we make? Look at the recipe. 2 slices of bread and 1 slice of cheese. That's what you need for a sandwich, right? Now you have 12 slices of bread and 5 slices of cheese. How many sandwiches we can make? 5 sandwiches, because you have only 5 slices of cheese, right? And each sandwich needs 2 slices of bread. So you will use 10 slices of bread and you will make 5 sandwiches. Now, in this example, what is the limiting ingredient? Now start thinking. Cheese is the limiting ingredient, which is completely used up, right? When you make 5 sandwiches, you used all the cheese slices you were given. So what is the excess ingredient? Bread. Of course, after you make 5 sandwiches, how many slices of bread will be left? 2 slices of bread will be left, because you had 12 slices to start with, right? So those 2 slices are called the leftovers, or bread is the excess reagent. In this, if you think about this as a chemical reaction, cheese is the limiting reactant, bread is the excess reactant, and how many sandwiches we could make, which is our product? 5, which was determined by the number of the limiting reactant, which was the cheese slices. Make sense? Okay, now let's look into a little more complex example. Well, this is from your book, but let's just focus on this one and think through it rather than just looking at the answers. So here is the construction of a model solar car. The picture shows like we need a frame, and then you need a solar cell, and you need a motor, and you need a set of wheels. A wheel set contains 4 wheels. So if you have these 4 pieces, then you can make a complete solar car. Okay? So this is what we are doing now. Now let's say, what do we have? So we have how many frames? This top one again shows the construction model. Okay? What do you need and how can you make a car? So we have 4 frames, we have 5 solar cells, we have 6 motors, and we have 12 wheels or 3 sets of wheels. Now the question is, using all those things given to you, how many complete cars you can make? 3. How many cars? 3 cars. Why? Because each car needs 4 wheels or a set of wheels, and you have only 3 sets of wheels there, right? So you can make only 3 complete cars. If we had another set of wheels, then we could have made 4 cars because we have 4 frames available. Let's say we had 4 sets of wheels, and no, 5 sets of wheels. Let's say we have 5 sets of wheels now. Can we make 5 cars? What is the problem now? There are not enough frames. So in each example, can you identify what is the limiting part? Say for example, in this part, as the picture is shown, the limiting part is the number of wheels. So all other parts, we can say they are all in excess, right? some of it will be left at the end of your construction project. There will be one frame left, there will be 2 solar cells left, there will be 3 motors left, right? Those are all excess parts, and the product, which is your complete car, that number is determined by the number of wheels available. So as the picture shows here, you can make complete 3 cars complete, and then these are all the excess parts which are left over. So this is what happens in a chemical reaction also. When we mix reagents, there will be one reactant which is always act as the limiting reactant, which is present in the smaller amount. Okay, and it's not as simple as just by looking at the amount and say, oh, this looks like, this is the smaller amount, so this could be the limiting reactant. No, it's not very simple as this cheese sandwich or the model car when it comes to chemical reactions. Guys, let me just go get another paper towel because my sinus is goodness. Okay, maybe I'm good for another half an hour. So, as we were talking about, wheel is the limiting part because it is completely used up, and the number of cars we made, that is also dependent upon the number of wheels we had. And as I said, if there were 4 more wheels, then we could have made another car, right? Okay. Now let's see at the molecular level what happens in a chemical reaction. Here is a simple chemical reaction which we have seen many times before, formation of water. We have the balanced equation in the bottom and the picture also. So we know that this is 2H2 plus O2 gives 2H2O molecule, right? And the picture also shows that there are 2 hydrogen molecules and 1 oxygen as the reactant, and we have the products. So if you look at this chemical reaction, the balanced equation, we learned before that the balanced equation, those coefficients tells us in what ratio they combine, right? The number of moles. So remember that number, the coefficient in front of each formula in a balanced equation tells us the relative number of molecules or moles that combine in a chemical reaction. Now, look at this picture now. How many hydrogen molecules we have in the reactant side? Please count. 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen is white, right? So, 8 molecules of hydrogen. And how many oxygen molecules we have? 5. So let's say they are going to react. How many water molecules are there in the right side? Let's count again. 8. And do you see an O2 molecule just left out? Okay. Now let's think through it. So the balanced equation tells us 2H2 combined with 1 molecule of oxygen forming 2 molecules of water, right? So the ratio is every molecule of oxygen reacting, you need 2 molecules of hydrogen. That is the balanced equation tells us. And when they react in that ratio, you get 2 molecules of water as the product. So if you have 5 oxygens there in the picture, ideally how many molecules of hydrogen you need for a complete reaction? 10, because the ratio is 1 molecule of oxygen with 2 molecules of hydrogen, right? So 5 molecules of oxygen means you need 10 molecules of hydrogen. Do you have 10 molecules of hydrogen there? You do not. You have only 8. What does that mean? We have, which one is the excess? We have an excess molecule of oxygen, right? Or if you think in the other way, 2 molecules of hydrogen need 1 molecule of oxygen. So 8 molecules of hydrogens are given to you. You need how many molecules of oxygen? Only 4, right? But you have 5 present. So 4 of them will be used up in the reaction, and whatever is present in excess will be left over. That is what you see on the right side. The 4 molecules of oxygen reacted with 8 molecules of hydrogen, formed 8 molecules of water, but you had an extra molecule of oxygen which is left out at the end of the reaction.
What if you had 9 oxygen, would you 9 hydrogen, would you have leftover oxygen and hydrogen?
If you had 9 hydrogens, how can you have exactly 9 hydrogen? Oh, 9 molecules of hydrogen. Okay, 9 molecules of hydrogen means 9 times 2 is 18.
So I mean, if instead of 8 right now it's 9, so there would still be 5 oxygen. Would it be 1 molecule of hydrogen and 1 molecule of oxygen left out?
No, it cannot happen like that. They won't break up like that. Just don't think ahead now. Right now, just look at this. When we do the rest of the equations, you will see that. So this picture is clear. Why we have 1 molecule of oxygen left over there? Okay. Now let's say we have a different picture. Again, water formation of water. Count how many you have on the left side and count how many you have on the right side. I'm sorry. How many hydrogens you have and how many oxygens you have, and what do you think how many water molecule will be there on the right side, and if there is something left out, what it would be. How many hydrogens we have?
2, 8.
Still 8. How many oxygens we have? 3 molecules. Okay. Now the balanced equation is 2 molecules of hydrogen needs 1 molecule of oxygen. So if you have 8 molecules of hydrogen, you need 4 molecules of oxygen. Do you have 4? You do not. So what is the limiting reactant? What is the excess reactant? Limiting reactant is oxygen. Excess reactant is hydrogen. Okay. Now, if oxygen is the limiting reactant, that will determine how many water molecules can form, right? What is the ratio between oxygen and water? Every 1 molecule of oxygen will give 2 molecules of water, right? So 3 molecules of oxygen should give 6 molecules of water. So if you were to complete this after picture, no, with my yellow ink you may not be able to see anything. So if you were to complete this after picture, you will have 6 H2O molecules and what else? 1 hydrogen molecule, one or 2? How many we have? Yeah, we have 8. So 2 of them will be left out, right? 2 H2 molecules also will be left out, because you can compare that also. Hydrogen water is 1:1 ratio, right? So if you had only 6 water molecules, That means 6 hydrogens must be used up for that. 6 hydrogen molecules. You have 8 to start with. So 2 will be left over, which is the excess reactant. So, well, that is the solution. So you can use that molecule ratios to determine the limiting reactant, as we just talked about. The 8 H2 molecule need 4 O2 molecules. There are only 3, therefore all the H2 cannot react. So H2 is in excess and O2 is the limiting reactant. So every chemical reaction cannot give you the molecular level picture. So we need to know some steps, or we need to learn how do we calculate this. That is identifying the limiting reactant and calculating the amount of product. So this is the steps. When you read the steps, it might be a little bit confusing, but when we do the problems, it will become clear to you. So this is where you start. First, you need to calculate the amount of one reactant, let's say B, A and B if they represent two reactants. Calculate the amount of B you need to react with the other reactant, or A, using the mole ratio from the balanced equation. So balanced equation is a must in limiting reactant calculations. So if the reaction is not balanced, first you have to balance the equation. Then only you can start doing the problem. And then compare the amount of B which you just calculated with the amount given. Then there are 3 cases. If the calculated amount is exactly the same as what is given, then there is no limiting reactant. It will react completely. If the calculated amount is greater than the actual amount, then B is the limiting reactant. B will react completely. If calculated B is less than the actual B, then the other reactant, or A, is the limiting reactant. Only A will react completely. Let me pick up an example and let's work through this. Then it will become clear to you guys. Do not try to by heart those steps. It's really confusing with A, B, greater, smaller, all that. So here is the balanced equation for the reaction of phosphorus and oxygen gas to form diphosphorus pentoxide. So the balanced equation, everyone notice the mole coefficients. What are the coefficients in front of P4? What is the coefficient in front of P4? 1, and 5 is in front of O2, and 2 is in front of P2O5. So if you say this in words, you can say 1 mole of P4 reacts with 5 moles of oxygen and 2 moles of diphosphorus pentoxide is formed. Right? That's what the balanced equation says. Okay. Now, there are 3 cases given here. We have to calculate what is the limiting reactant in each of the cases. So the first case is 0.5 mole of P4 and 5 mole of O2. How do we decide which one is the limiting reactant? So balanced equation says 1 mole of P4 needs 5 moles of O2. So in a typical question like this, what you do is you just pick up the first quantity which is given. Okay? So you are given 0.5 moles of P4 and you calculate for for 0.5 moles of P4, how many moles of oxygen you actually need using the mole ratio. What is the mole ratio between oxygen and phosphorus? You want to find out how many moles of oxygen you need. So which one goes on the top? Oxygen, which is 5 moles of O2 and how many moles of P4? 1 mole of P4. So how many moles of oxygen you need? 5 multiplied by 0.5, 2.5 moles of oxygen. This is what you need, right? Now look in the question. How much oxygen is given to you? 5 moles. You need only 2.5, but 5 moles is given to you. So what is the excess reactant or what is the limiting reactant? P4 is the limiting reactant. Oxygen is present in excess. You need only 2.5 moles. But there are 5 moles. That means that is in excess. Right? So if oxygen is excess, then the other reactant has to be the limiting reactant, which is P4. This is how you decide which one is the limiting reactant. Pick up the first amount, whatever is given to you, and calculate what is the theoretical amount of the other reactant you need using the mole ratio concept which you learned in previous sections. Then compare that amount with what is actually given to you. Then make the comparison. If you are given more than what you need, then that is present in excess. If you are given less than what you need, then that is present, that is the limiting reactant. Let's do the rest of the cases also so that it will become more clear to you. So the second case, we have 0.2 moles of P4 and 1 mole of O2. So as I said, the first step is calculate theoretically how many moles of O2 you need for, come on, okay, how many moles of O2 you need for 0.2 moles of P4. How do we calculate that? 0.2 mole of P4 multiplied by the mole ratio again from the balanced equation, which is 5 O2 per 1 P4. So how many O2 you need?
1.
You need 0.2 times 5, which is 1 mole of O2. So this is what you need. Now you look at the question. How much is given to you? You are given that much amount, right? You need 1 mole and 1 mole is given to you. So there is no limiting reactant. It will react completely. Both of them, P4 and O2, will react completely as it is given. There is no limiting reactant or no excess reactant. Now the third case, you have 0.25 moles of P4 and 0.75 moles of O2. Again calculate for 0.25 moles of P4 how many moles of O2 you need according to the balanced equation. So 0.25 moles of P4 multiplied by mole ratio 5 O2 per 1 P4. How many moles of O2 you need? You need 1.25 moles of O2, right? Now compare with what you are given. You need 1.25. Do you have 1.25 given? You have only 0.75 given. So what does that mean? Oxygen is the limiting reactant. The other one is the excess reactant. Is things getting clear? This is why that mole ratio, if you are not sure about it, I told you before you go for the break, learn section 2 and 3 of this chapter thoroughly, because without that you cannot understand limiting reactant problems. So if you haven't done so, I have no words. Go and do it tonight. So, as we have done the solutions, so you pick up the first part given to you and calculate how much you need